Hey there, science fans! Let's dive deep down to the Earth's core, where the mysteries of our planet unfold. It's like the planet's beating heart, super hot and essential for life as we know it. Imagine it as the engine that keeps everything running smoothly on the surface.
We're talking about a solid iron ball, almost as big as the moon, with temperatures hotter than the sun's surface. It's an incredible powerhouse of energy and heat. Surrounding this inner core is the outer core, a swirling sea of molten iron. This layer is in constant motion, creating dynamic and powerful forces.
Now this molten iron isn't just chilling, it's constantly moving, creating electric currents that are vital for our planet's magnetic field. These currents act like a giant dynamo, generating a powerful magnetic field that surrounds our planet. This magnetic field is crucial for many reasons.
This magnetic field is our invisible shield, protecting us from harmful radiation from the sun. It deflects solar winds and cosmic rays that could be dangerous to life, and keeping our atmosphere from being blown away into space. Without this protection, our planet would be a barren wasteland. Without the Earth's core and its magnetic shield, life as we know it wouldn't exist. It's the unsung hero that makes our vibrant, thriving world possible.
Imagine our Earth's core suddenly stopping its spin. It sounds like something out of a science fiction movie, right? While it's highly unlikely, thinking about it helps us understand just how important this spinning core is.
So what could possibly cause such a dramatic event? One theory suggests it could involve the complex interactions between the inner and outer core. Picture two spinning tops, one inside the other. If they influence each other's spin, maybe, just maybe, they could come to a standstill.
Another theory points to external forces like a massive meteor impact, disrupting the Earth's rotation and potentially affecting the core's spin. While these scenarios are far-fetched, they highlight the delicate balance that keeps our planet humming. Let's say the Earth's core did stop spinning. This hypothetical scenario might seem far-fetched, but it could have profound implications for our planet. One of the most immediate and dramatic consequences would be the weakening or even complete disappearance of our magnetic field. This field is crucial for life on Earth as it acts as a protective barrier.
Remember that invisible shield protecting us from the sun's radiation? It's our magnetic field, and without it, we would be in serious trouble. It would be like taking down our defenses and leaving ourselves exposed to a constant barrage of harmful particles. These particles can cause severe damage to living organisms and electronic systems.
Without the magnetic field, our compasses would go haywire, no longer pointing north. Navigation, which relies heavily on magnetic compasses, would become incredibly challenging. But it's not just about getting lost, our technology would be in big trouble too. Many of our modern devices depend on the stability provided by the magnetic field.
Satellites could malfunction, leading to a cascade of issues in communication and data transmission. Communication systems could go down, affecting everything from phone calls to internet connectivity. And power grids could be vulnerable to solar storms, potentially causing widespread blackouts and disruptions. The northern lights, usually only visible near the poles, might be seen across the globe as charged particles penetrate deeper into our atmosphere. While beautiful, this would be a sign of a much larger problem.
Here's a mind-bending thought. The Earth's rotation, the cycle of day and night we take for granted, is also influenced by the spinning core. If the core were to stop, it could mess with our planet's spin like never before.
We might experience changes in the length of a day, either shorter or longer, as the planet adjusts to the core's stillness. While a few seconds here or there might not seem like a big deal, over time, these changes could add up, affecting everything from our calendars to our internal clocks.
But it's not just about timekeeping.
Changes in Earth's rotation could also trigger shifts in tectonic plates, leading to more frequent and intense earthquakes and volcanic eruptions.
Section 5. Life under siege, a struggle for survival. With a weakened magnetic field and a disrupted rotation, life on Earth would face unprecedented challenges.
The increased exposure to solar radiation would pose a significant threat to all living organisms. Think of it like getting a sunburn, but on a much larger scale.
Plants, animals, and humans would be more susceptible to DNA damage, increasing the risk of cancer and other mutations.
The delicate balance of ecosystems could be thrown into disarray as species struggle to adapt to the harsh conditions.
Marine life, especially vulnerable to changes in ocean currents and temperatures, would also face severe consequences. Section 6 Rumbles and Eruptions, a restless planet. Our planet is constantly in motion, a dynamic and ever-changing entity. Remember those tectonic plates we talked about? These massive slabs of rock make up the Earth's crust and are always on the move. Well, a stationary core could really shake things up. The energy stored in these plates would be released in a dramatic fashion.
The Earth's crust is made up of these giant plates that are constantly moving, albeit very slowly, on top of the mantle. This movement is driven by the heat from the Earth's core. The core's spin plays a crucial role in this movement, acting like a giant engine that powers the shifting of the plates.
Now, imagine the core suddenly stopping. This would be an unprecedented event in Earth's history. It would be like slamming the brakes on a moving train. The sudden halt would send shockwaves through the planet. The plates could jolt and grind against each other with unimaginable force, triggering earthquakes of unprecedented magnitude and unleashing volcanic eruptions on a global scale. The destruction would be catastrophic.
Dormant volcanoes might roar back to life, spewing ash and lava into the atmosphere, further disrupting the planet's climate and threatening life as we know it. The skies would darken, and the air would become thick with ash, making it difficult to breathe and blocking out sunlight.
Section 7. Climate Chaos, the Winds of Change. The Earth's climate is a complex and interconnected system, and the core plays a surprisingly important role.
The magnetic field, generated by the spinning core, helps protect our atmosphere, which in turn regulates our planet's temperature. But with a weakened magnetic field, our atmosphere would be more vulnerable to being stripped away by solar wind, leaving us exposed to the full brunt of the sun's energy.
This could lead to runaway greenhouse effects, causing temperatures to soar and ice caps to melt at an alarming rate. Sea levels would rise, flooding coastal areas and displacing millions.
Weather patterns would become more extreme and unpredictable, with intense storms, droughts, and heat waves becoming the new normal.
Section 8. Seeking Answers, the Quest to Understand. The scenario of the Earth's core stopping is, thankfully, highly unlikely. However, exploring these possibilities allows scientists to delve deeper into the intricate workings of our planet and appreciate the delicate balance that makes life on Earth possible.
Researchers use sophisticated instruments to study the Earth's core, analyzing seismic waves from earthquakes to create images of this deep, hidden world. By understanding how the core behaves, scientists can better predict and prepare for potential threats, such as solar storms and geomagnetic disturbances.
The more we learn about our planet's heart, the better equipped we are to protect it and ensure the well-being of all life that depends on it. Section 9. Beyond the Horizon, a glimpse into the future. As we continue to explore the cosmos and search for life beyond Earth, understanding the role of a planet's core becomes even more crucial.
Scientists now consider the presence of a magnetic field as a key factor in determining a planet's habitability. Planets without a protective magnetic shield are exposed to the harsh radiation of space, making it unlikely for life to arise or survive.
Studying the Earth's core provides valuable insights into the conditions necessary for life to flourish in the universe. It's a reminder that we are part of something much larger than ourselves, and that the fate of our planet is intricately linked to the cosmos. Section 10. Lessons learned, the importance of our planet. The hypothetical scenario of the Earth's core stopping is a stark reminder of the delicate balance that sustains life on our planet. It highlights the vital role that this hidden, molten heart plays in shaping our world and protecting us from cosmic threats.
While the possibility of such an event might seem remote, it underscores the importance of understanding and respecting the natural forces that govern our planet. It's a call to action to appreciate the interconnectedness of Earth's systems and to promote responsible stewardship of our environment.
By learning about our planet, we gain a deeper understanding of ourselves and our place in the vast universe. Section 11. Our Role to Play, Guardians of Earth. As inhabitants of this remarkable planet, we have a responsibility to protect it, not just for ourselves but for future generations.
By supporting scientific research, promoting environmental awareness, and advocating for sustainable practices, we can help ensure that Earth remains a vibrant and habitable home for all living things. Remember, there's no planet B.
It's up to each and every one of us to be guardians of this pale blue dot, our only home. Let's work together to create a future where both humanity and nature can thrive in harmony. And hey, keep looking up at the stars and never stop asking questions about the wonders of our universe.